Hello, good morning, and welcome to Refactoring Bitcoin. After some theoretical videos, I now want to continue with the actual refactoring of the Bitcoin kernel codebase. Quick recap, what happened so far, how we got here. So I took the C header from the Bitcoin kernel, from Bitcoin Core, and I translated the C API, just those function declarations, into classes, into structures. I removed the prefix of the function name and organized the classes that belong together into structs. And I just used the names that were given, so the names for the classes and the function names. I took the names that were given in the C header. And then I extracted some parts of those classes into this primitives.hpp. This is the classes, the TXID, block hash, transaction output, transaction input, scriptPubkey, transaction output, transaction, and block. You see? And then I also started implementing the getter functions for outputs, for example, and we introduced type erasure to give the client a range of outputs without leaking the actual type that we have internally. So today I want to continue here, and I just saw that ranges, this header is not used directly in this file, so I can remove it. And then I want to have a closer look at those classes here. We have transaction output, transaction input, scriptPubkey, transaction output. And I think the names are quite close together, especially the transaction out point and transaction output. I easily confuse them. I don't even know whether I just said it correctly. So I wanted to know, is that the original naming that was used by Satoshi Nakamoto? So I switched here to the source code that I found in the Bitcoin forum. There's a post from December 13, and this guy here claims that he has an archive directly from Satoshi Nakamoto, and he posts the source code here. This is the source code from 2008. In the source code, we see we have the copyright header and then a forward declaration of a bunch of classes. And we notice that all the classes have a prefix C. That was the notation that Satoshi Nakamoto was using. But if we ignore the prefix, we also see the names, okay? So he had a class here, outPoint, okay? It didn't start with transaction, so it's just outPoint. It's also interesting, there was an inPoint, and then the transaction is called transaction, and the block is called block, but the transaction input and transaction output were just called TX in and TX out. So I think it would be better if we stick to those names without the C prefix. We will not use a prefix, but instead use a proper namespace. But we should stick to those names here. And we can look further down in the source code. So there's a bunch of integer constants, then some global variables. And we notice also that the variable names all have a prefix. So this is influence from Hungarian notation. It's not exactly following the Hungarian notation, but we see, for example, that we have a map here, and the variable name starts with map. And we have a 32 byte integer, and this starts with hash. Then we have here a pointer to a block index, and the variable starts with p index. Apparently, the p stands for pointer, so it's a pointer to an index. We have this number here that begins with n, and we have yet another pointer to an index that starts with p index. We have another number that starts with n. And here, this is an integer, but it starts with f. So f in Hungarian notation stands for flag. This is used for booleans. So this is a boolean setting It's called generate bitcoins, but it's the setting whether mining is enabled for the node or not. So this is a Boolean, even though the type is actually int. And then we have some function declarations. Those are free functions here. And in the functions, we also have the argument types, the argument variables here. We see numbers start with n here also. This one is interesting. This is a C-style string, right? A pointer to a constant char. And this has the prefix PSZ, which stands for pointer to a string with a 0 terminator. Okay, and numbers have prefix n. Here we see that this is the class is key. If we ignore the prefix c, we just call it key. So he would prefix the variable with key, but since a key is just self-describing, so it just uses the word key without anything following. But here, for example, we have a variable of type wallet tx, and the prefix is wtx. Okay. And here we have a variable that starts with an nf. And here Satoshi also already actually also used the Boolean data type rather than int. It's also interesting here, pointer to node starts with a p in multiple places. This string starts with str. Here we have a script that starts with script. Another number that starts with an n, and here we see some inconsistency. Okay, before above here we had the wallet tx with the prefix wtx. Here as well we have a wallet tx with the prefix wtx, but here we just have tx. So this is not on purpose. I think this is a typo. This is just not following the naming convention, the notation directly. But what is the purpose of this notation here? I want to show you, if you scroll down, further down in the source code where we have some deep nesting. Let's look at here, this code, for example. Here we are deep down in the code. So this is a member function. Inside here, we have an if condition and a for with a nested if, and another for loop with an if condition, and then another if condition deeper. And here, for example, we want to know what is this condition here actually checking. And of course, if this was an IDE, I could hover my mouse here over this variable, and I would get a dropdown with some information where this variable is defined, what the type is, even what the documentation of this variable is. But if we have just this black and white text, like if it was printed on paper, then the prefix tells us the type information. So we know we can assume that this check here is comparing two numbers, okay, rather than any other data type. And this flag here is set to a Boolean condition. So this is truly a Boolean. We know that from the prefix. Okay, but there are also disadvantages of this naming conventions, of this Hungarian notation, and this is it makes refactoring harder. If we want, for example, if we want to wrap a built-in type into a custom type, and we want it to behave exactly like the built-in type, just with some additional constraints, then we can easily do that. We can wrap that. But then the question is, should we now change all the variable names? Should we replace the prefix with the actual class name or what? And therefore, in today's code, we prefer not to use the Hungarian notation. Okay, so and this is what I wanted to do in the C++ kernel API. I want to stick to Satoshi's names, but not his notation. Okay, so I want to drop the prefixes, but use the original names. So we go back to to the source code and look at the actual classes. Especially we are interested in those classes here. So we have this out point, which has a hash and n. In our source code, we had index and txid. So this is maybe something that we want to keep in mind. Then txin has an out point in the script. And I also wanted to show you something. In the source code of the C++ kernel, let me quickly show it here. We had this class here, scriptPubkey, and the transaction output has a getter function called scriptPubkey that returns a scriptPubkey. So what is a scriptPubkey? I could find the name in Satoshi's original source code, but it's not used as a thing. So when did it actually became a thing? So I looked in the Bitcoin Core source code, and I found that there is even a class called a scriptPubkey man. Okay, I find that funny. It reminds me. It sounds like there was someone who was bitten by a radioactive scriptPubkey and turned into scriptPubkey man. Of course, this class is there to manage multiple scriptPubkeys. But what is a scriptPubkey? And I think this is just a misunderstanding from Satoshi's notation that he used. We see here, here we have this variable. It's called scriptPubkey, or rather, I would just not read the prefix. I said the value, the type prefix here is not something that we read. So I would say the name of this variable is value, and the name of this variable is sequence, and the prefix is just the encoded type information. Like we can say this is like the color. The color of the variable is encoded in the prefix, and the actual name of the variable is just what follows after the prefix. So the same should be true here. Script is just the color of the variable. It's the encoded type information. You see, it's a script, but the name of that is just pubkey. And we can see here in the documentation, Satoshi wrote documentation for this class, an output of a transaction. It contains the public key that the next input must be able to sign with to claim it. So we see that Satoshi refers to this variable in documentation as the public key. And also above here, we have another example. I just want to read the documentation first. An input of a transaction, it contains the location of the previous transaction's output that it claims and a signature that matches the output's public key. So signature is the term that he uses to refer to this variable. Okay, so the prefix of the variable is script because that's the type, but the actual name of the variable is sig, which is short for signature, which he also uses to refer to in documentation. So a script sig and a script pubkey is not a thing in the original code. It became one later by misunderstanding Satoshi's naming convention, or by misunderstanding Satoshi's notation. So now we go back to the source code and we want to make the changes to match it. So this transaction output, we just call it sorry, I said it wrong again. The transaction out point, we just call it out point. And we also reorder the variables to match the ordering that Satoshi had before. So this is the hash. Maybe we should also call it hash. And this was just called n. But n is rather short, and so I think it's better to be more explicit. So I would prefer to continue index. So then the transaction input is just txin, and this variable here, this property is an output out point. And the name of that, so the type is out point, but the name of that is prev out. Okay. So then the script pop key is something that we should get rid of. We should turn this into script. But also we see here that the only thing that clients of the kernel API can do at the moment is initialize that from a buffer and then write it to a buffer. So why don't we just use the buffer for now directly, and later we may decide to expose a script type to clients of the kernel API. But apparently the C API was designed with the idea in mind that clients will not use it or may not use it. So we will just use the buffer for now, and later if we figure out that clients need to do other things with the script, we actually can return, or we can actually expose a script in a later version. So I just want to replace scriptPubkey with the actual buffer and then get rid of this class. So transaction output will be called txout. Okay, we fix the constructor name. Okay, and then the name, we should drop the prefix and should just call this pubkey. Okay, but it's not exactly clear because this script here contains more than just the public key. It's actually the script that is used to check whether this is spendable, right? So I want to, I took this book here, Mastering Bitcoin, and looked how is it actually described? How is an output described? And I found the following. I want to read from the book. The first field of a specific output is its amount, also called value in Bitcoin Core. Yeah, this is something else that we noticed. The tx out in original in Satoshi's implementation, he had a data member called value, which we do not have here. We have this amount. So yeah, I think amount is actually more explicit than value, because value in C++ is such a loaded term. It could mean anything. So I think amount is better here. What I want to change is, since this is it appears first in the serialization, I also want to move it to the beginning. I want to have it first as the first member, and I also want to have the amount first in the constructor. So I move that here, and I continue. What else do we have in an output? Is an output script. The output amount is followed by a compact size integer indicating the length, blah, 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 of the output script. The script that contains the conditions that will need to be fulfilled in order to spend the Bitcoins. So this is the output script. So maybe instead of pubkey, we should call it output script. But since it's the only script in a tx out, I think it's sufficient to just call it script. Script. So the script of a tx out is an output script, of course, and I think that's more clear than pubkey, and also better than scriptPubkey, of course. So then the transaction is fine. I just need to make sure that this transaction output is called txout, and this range of inputs is a txin. Good. And now what we can do is we can copy this type here, and I want to have inputs type. Inputs type is we do the same for txin. here, and this will be the return type of my inputs. This will now just be inputs type. So the other thing that I want to do, let's get rid of this placeholder that we introduced, this range. I want to get rid of that, and in all places where it was used, use the actual any view that allows us to return the range without exposing the type information. So we see that the only place that it's also used is here. We copy that, put it into the block. This will be our transactions type, because the member is called transactions. To use this as a return type, and this will be transaction. And here as well. Good. And this is now the API that follows the names of Satoshi's original implementation much closer. And this will now be the base of our implementation. I will do that in the next video. So thanks for watching, and goodbye.